Good morning, precalculus. So today we're going to use matrices to solve systems of equations using something called row operations. We will use matrices to solve systems of equations two additional ways throughout the series of lessons that we have, but the first way we'll use is row operations. Go ahead and do this warm-up based upon the lesson from yesterday. Okay, so here are your answers. The first, you're just subtracting every element of C from every element of A, and because they're the same dimensions, you can do that, and here is your result. The next one is a scalar multiplication. You're pretty much just distributing a -3 in here on A, so your result will also be a 3 by 2. So 1 times -3 is -3, and so on. I'm going to wait on this one, but we'll jump to B times C. So remember, when you're multiplying two matrices, you have to look at their dimensions. B is a 2 by 2, C is a 3 by 2. They have to have an inner match, and we don't, so you cannot multiply them together. All right, so let's look at the third one here. So this one we had to do A times B, and I needed more space. So here's A and B. First thing I do is look at their dimensions, 3 by 2 and 2 by 2. So I have that inner match. Right here's the inner match. So my result will be the outer dimensions, or a 3 by 2. So I give myself space, 3 rows, 2 columns. And remember, you're taking row by column. So it's this row, first row, times first column. So 1 times 7 is 7. 6 times -1 is -6. And you continue to do that, each row times each column. And since this is row 1, column 2, it goes in row 1, column 2 position. And likewise, row 2, column 1, row 2, column 2, row 3, column 1, row 3, column 2. And then I simplify all that, and here is your result. Hope you did well and remembered how to do it. The first thing we need to do in order to solve a systems of equations using matrices is to write a linear system as an augmented matrix. So this is an augmented matrix right here. I take the coefficients of the equations in standard form. It must be linear, so first degree variables. And then I took the solution and make that its own column off to the right, and we have this line here separating your coefficients from your solutions. And you definitely have to fill in 0 coefficients, so every space should be filled in. And this is a 2-variable system, so you have a 2 by 2 coefficient matrix and then a 2 by 1 solution matrix. If it was a 3 by 3 system with 3 variables, you'd have a 3 by 3 coefficient matrix and a 3 by 1 solution matrix. And so this here is your coefficient matrix, and this is your solution matrix. So now I want you to try it on your own. Go ahead if you need to rewind the video so you can see again, but try this, pause the video here, and then I will show you the solution. So the first one was pretty straightforward. Everything was organized nice and neat, so you're able to just put the new numbers in. But the second one, I hope you saw that you're missing a y in this equation and you're missing a z in this equation, so that's why we have 0 coefficients. And also the solutions were on the left-hand side, so you had to move the -2 over and move the 7 over. So that is the correct augmented matrix for this set of equations. Likewise, you can do it the other way. If you have an augmented matrix, you can rewrite it as a system of equations. So I will do the first one right now and then pause the video and you can do the second one. So remember that each of these is x and each of these are y, and then there's your solution. Since this is the coefficient matrix right here. So we have -2x plus y equals 3, and x plus y equals -2. All right, pause the video and use the second one. We'll use the variables x, y, and z. And there is your solution. Pretty easy since it was already set up, and we're back to the standard form on each of them. So now we're going to solve systems of linear equations using matrices and do something called row operations. Here are your rules for row operations. Read through these. Number 1, interchange any two rows. You're allowed to replace a row by a non-zero multiple of that row, and you're allowed to replace a row by the sum of that row and a constant non-zero multiple of some other row. So here's your notation. And this on the left is your result based upon what row number, and this is what you're doing to it. So here's the matrix we're starting with. It's an augmented matrix, and we are going to rewrite it after the results of this row operation. So when we rewrite it, it will look just the same. So we are not changing row 1, we're only changing row 2. This is row 1, and this is row 2. So I'm just going to rewrite row 1 since it does not change. Now, when I get to row 2, I'm going to take -3 times row 1 and add it to row 2. So let's just do that. -3 times 1 is -3. I add it to 3 and I get a 0. That is really important, 0. So actually what you're going to do is be choosing the right row operations to make zeros. All right, let's do it to the next one. -3 times row 1's -2 is 6. 6 plus -5 is 1. And you have to do it across the whole row. So -3 times 2 is -6 plus 9 is 3. That is applying row operations. I hope you see some similarities with these rules and what you did in the elimination process of solving a system of equations. To finish our process, we're going to need to put the matrix into something called a row echelon form. And what is that? So row echelon form, the entries in row 1, column 1 is a 1, and zeros appear below it. So I'm just going to draw a quick 2x2 augmented matrix. And what it needs to look like is a 1 here with 0 here. And we actually already have that in this picture down here. And then we need to have the first non-zero entry in each row after the first row is a 1, zeros appear below it. And then any rows that contain all zeros to the left appear at the bottom. So what it looks like is you want it to look like this. And then this will be whatever the solution numbers are that are the result. And the nice thing about this is when you think about this being x and y, you end up with x equals a and y equals b, and then you quickly have your solution. So now we're going to do that to this matrix here. So this is the result of what we did on the last slide. And let me move this up. And my goal is to make this right here a 0. We already have the 1 and the 0 and the 1. We just need a 0 here. So looking at this, I'm going to take advantage of the fact that I have a 0 here to help me make this a 0 here. So I'm going to take row 1 and I'm going to multiply 2 times row 2 and add it to row 1. Now, why did we choose 2 times row 2? Since I have a 1 here, I need to figure out what makes that a 0, and 2 added to -2 makes 0. I don't have to worry about changing my first column because I have a 0 here. So let's see how that works. If I take row 1, well, first of all, I can rewrite row 2 because that's not changing. So great. But row 1, take 2 times row 2. So 2 times 0 plus 1 is 1. Okay, and that doesn't change. And then 2 times 1 is 2, added to -2 is 0, and I have to do it here. 3 times 2 is 6, added to 2 is an 8. It's actually easier to see it not spelled out like this, but just done. So I'm going to redo this real quick and talk through it. So I'm going to rewrite row 2 since it's not changing. And then I'm going to take 2 times row 2, so 2 times 0 plus 1 is 1. 2 times 2 plus -2 is 0. 2 times 3, which is 6, plus 2 is 8. And that shows me that x equals 8 and y equals 3 in this system of equations. All right, so this is all the steps written out. I would take a moment, read through this. It's there for those that like to have step-by-step very clearly written out, but I think you might find it easier when I just do a bunch of examples. Okay, so we're going to do this example. Feel free to pause it as we go along whenever I go too fast. So the first thing I want to do is write this as an augmented matrix. So I will do that. So we have a 2, a 2, a 0, a 6, a 1, a 1, a 1, a 1, a 3, a 4, a -1, and a 13. Excellent. All right, so let's write down what our goal is. Row echelon form wants us to have a 1 here and zeros below. And then it wants us to have a 1 here and 0 below and a 1 here. So it wants 1s on the diagonal and zeros below it. These values could be left with anything else. Oh, whoops, I messed that up. That needs to just be a line. And then over here will be values A, B, and C. Now, C is then known, and then you can use C to find B, and then you can use B and C to find A. Sometimes we will go further and put these in as zeros, which is then called reduced row echelon form. But we're just going to go to row echelon form. It's easier. All right, so that's our goal. And the first thing we can see is we need a 1 up here, and we're allowed to interchange any 2 rows. So I'm going to take row 2 and switch it with row 1. Switch. I'll try to write down each step as we go. So now this is row 1, and this is row 2. Okay, so far we got the 1 up there. Next I need to go for these to become zeros. So in order to do that, the first rule I'm going to do is row 2 is going to be replaced with -2 times row 1 plus row 2. Let's just look at that rule. Row 2 is going to be replaced, and if I multiply 1 times -2 and add it, that becomes a 0. And row 3 is going to be replaced. Likewise, I'm going to multiply -3 times row 1 and add it or replace row 3. So I'm going to do both of those steps together and have my new result. Notice that row 1 isn't changing, so I'm just going to rewrite row 1 with no change. And then let's do the row operations. So row 2, -2 times row 1 is -2 plus 2 is 0. And I got to keep going. -2 times 1 is -2 plus 2 is 0. Oh, I got another 0. And then -2 times that plus 0 is -2. -2 times 1 is -2 plus 6 is 4. All right, we're done with that row. And the third row, -3 times 1 is -3 plus 3 is 0. And if these aren't zeros here, you did something wrong or you chose the wrong row operation. Keep going. -3 times 1 is -3 plus 4 is 1. -3 times 1 is -3 plus -1 is -4. -3 times 1 is -3 plus 13 is 10. All right, we are going to keep moving along here. Okay, so now I've got my first column, my first row in good shape, but my second one, I want to get a 1 right here. So I'm going to switch row 2 and row 3. So let's see what we get when we do that. Row 1 doesn't change. And row 3 is now row 2. And row 2 is now row 3. Why did I do that? My goal is to get the 1 and the zeros below, then the 1 and the zeros below, and I need a 1 here. So I am almost done. How am I going to get a 1 here? So one thing you can do is you can rewrite any row as a non-zero multiple of itself. So what would I multiply row 3 by to get a 1 here? Well, I would multiply it by -1/2, right? If you do -2 times -1/2, you're going to get 1. So let's now complete that row operation. The first two don't change. And the last one, 0 times -1/2 is 0. 0 times -1/2 is 0. -2 times -1/2 is 1, my goal. 4 times -1/2 is -2. And I have now had it in row echelon form. And I can finish solving my system of equations. So remember, this is x, y, and z. So we know z equals -2. We know y minus 4z equals 10. So y plus 8 equals 10, and y is 2. And lastly, x plus y, so plus 2, plus z, so minus 2, equals 1. So x equals 1. And that is the solution to my system of equations. Let's just write that as an ordered triple. 1, 2, -2. And we are done with the problem. This is the same problem on the last slide, but goes through those same steps again, one step at a time, through kind of how the textbook had written it out, which is the same process, but some people like it written out. So I will just go through this slowly so that you can read it and make sure you understand. Feel free to pause it with each page. And there you have it. Here is another example that we will work through together. So the first thing I'm going to do is write this as an augmented matrix. So 1, -1, 1, 8, 2, 3, -1, -2, 3, -2, -9, 9. Notice that we already have the 1 here. So the first thing we have to do is perform row operations for row 2 and row 3. So I'm going to first rewrite row 1. Now row 2 is going to be replaced by -2 times row 1 plus row 2. And row 3 is going to be replaced by -3 times row 1 plus row 3. And replacing each of those. So when I do -2 times row 1, you end up with a 0. That was your goal. -2 times -1 is 2, plus 3 is 5. -2 times 1 is -2, plus -1 is -3. And do the whole row. -16 plus -2 is -18. Row 3, -3 times 1 is -3, plus 3 is 0. -3 times -1 is 3, plus -2 is 1. -3 times 1 is -3, plus -9 is -12. And -3 times 8 is -24, plus 9 is -15. All right, the next thing I'm going to do is I need to get a 1 in the second row, second column, right there where the 5 is. So I'm just going to switch row 2 and row 3. All right, so change colors. We're going to switch row 2 and row 3, and our new matrix looks like this. No change to row 1. Here's row 3, and here's row 2. All right, so now I need to get the 5 to be a 0. So I am going to take row 3 and replace it with -5 times row 2, so use the one above it, plus row 3. And it's not changing row 1 or row 2. But it will change row 3. So -5 times 0 is 0, plus 0 is 0. -5 times 1 is -5, plus 5 is 0. -5 times -12 is 60, plus -3 is 57. And then -5 times a -15 is 75, plus -18 is also 57. All right, so we are getting closer to being done. Let's give ourselves some more room. And I will go to a new color to finish the problem. So I need this right here to be a 1. And what I'm going to do is take row 3 and I'm going to multiply it by -157. So I'm going to divide both by, not negative, by positive 157th. And I will end up with a 1 there. So our new matrix looks like this. Row 1 has not changed. Row 2 has not changed. And row 3, when you divide 0 by 57, you still have 0. 0 divided by 57. 57 divided by 57 is 1. And doesn't this work out nicely? 57 divided by 57 is also 1. So now I can finish solving the system. We end up with, remember this was x, y, z. So z equals 1. And then we have y minus 12z, which is 1, equals -15. So when you add 12, you get y is -3. So we found 2 variables. And the last one, you just have to plug in. So we have x, and then -1 times -3 is +3. And then 1 times z, which is 1, equals 8. So x equals 4. And our ordered triple is 4, -3, 1. And we finished the problem. And that is it for this lesson in terms of using matrices to solve a system of equations. In the next lesson, we'll look at some word problems as well as looking at inconsistent or dependent systems and see what happens with the matrices. Go ahead and try your homework assignment.